Okay, so today it's called fractional exponents, and this does sum it up really well, but you don't know what all this means yet. I'm going to show you in a moment the fractional exponents. All right, so if I was going to solve this problem when it has to the x, the way I do it is by making the bases the same. Do you remember that? Let's see if you remember that. 3 and 81 can have the same base. Who remembers 3 to the what is actually 81? 3 to the 4th, good. 3 to the 4th is 81, and I'm replacing the 81 with a 3 to the 4th, and everything else I'm just copying. Don't forget to copy the x down there. Do you see I just replaced the 81 with a 3 to the 4th? That's the only difference. Then the bases are the same, and then the powers are the same, and you're like, wait, there's no power over here. Then that means there's a 1 there. So then 4x must equal 1. And anybody in here can solve that and say it's 1/4. But do you get that that means x to the 1/4? Sorry, I said that wrong. X equals 1/4. Sorry. And that means that our original problem was meaning that 81 was to the 1/4 power. By now, I've already taught you the square root kind. So I hope this is easy. Tell me you know that answer. What's the answer? 3. If you hadn't caught this yet, when there's a fraction exponent, the bottom part, that's the roots. I usually make this dumb joke, the roots go on the bottom, just like in plants. Because you're going to have to pick where to put the root. See, when the problems get more complicated later, it's going to be like this. And you'll be like, okay, I know it's 9 to a power, and I know the whole lesson's called fraction exponents. So I know there's a fraction exponent, but where should I put what? And people just say, well, it must be in order, so I'll put 3/5. And then they're like, well, wait a minute, is this the kind that's not in order, so it's 5/3? But I say, put the roots on the bottom, just like in plants. So where is the root? Is that a root, or is that the root? Is the 3 the root, or is the 5 the root? The 3 is the root. So the roots go on the bottom, just like in plants. Do you get how it's actually like that? Okay, so here's a typical set of questions. They're really asking square roots or third roots or fourth roots or whatever. I betcha most of you can answer them already. Do you know the third root of 64? Hint, it's not 3. That would have been 27. 4. Because 4 times 4 times 4 gives you 64. You don't write 4 times 4 times 4. What is the answer to the question? 4. Just a number that when you times it by itself 3 times would give you the answer. Okay, so what's this answer? It's not a third root, it's a second root, but usually we call it the square root. 7. Raise your hand if you had 7. Okay, awesome. And the last one, fourth root of 16, 2. Because 2 times 2 times 2 times 2. 2 times itself 4 times. I'll give you the answer. All right. Moving on to this kind. On this kind, you have to do 2 things. You have to take the root and then put it to this power. What is the third root of 8? 2. And then you put it to this power. So it isn't 2 anymore. It's 2 squared. So what is it? 4. Are you paying attention or just staring at the board? You should be writing. You should be writing. It'll be helping you remember it. Okay, on to the next one. This is the fourth root of 16. What is the fourth root of 16? 2. And then you put it to the third. Don't say it. I'm going to ask some random person. If you haven't already, answer all of these by first doing this root and then putting it to that power. All right? All right, dice of destiny. 16 to the 3/4 power. Row 5. 1, 2, 3, 4, 5. Person 4. That's you. 8. So you say it's 2 and then to the third, and that makes 8. Raise your hand if you had 8. You're right. Okay, on to the next one. Row 6. Person 3. That's you. LM. You can do it in your head really quick. Square root of 4. 2 to the 5th. Say it again. 32. Raise your hand if you had 32. Okay, good. And the next one. Row 5. Person 4. It's you again. Weird. Really likes you. Raise your hand if you had 16 for that one. Okay, good. And the last one. Row 4, person 1, and that's you. What? You need something? Yes, you did. Hold on a second. Okay, so there's the last one. Raise your hand if you had 9. Awesome. Okay, I think you're getting how the general idea of fraction exponents work. It's not that bad. Well, we're going to be solving equations with them in it, and it's not that hard, but you got to put this to a power. Please don't say multiply by 3. That's wrong. You put it to a power of 3 in this case. Why? Because 1/3 times 3 would give you an x to the 1. And isn't that just the same as x? And that means we solved for x. What is 3 to the 3rd? 27. All right. Do you remember on complex equations, you'd always start by adding or subtracting first? Notice it's the end of the please excuse my dear Aunt Sally list. You always do the add, subtract stuff first. Then you do the multiply and divide stuff. And the last thing you do is power stuff. Is there any add or subtract stuff you could do here? So do it. What is it? Minus 8. Minus 8. X to the 1/4 is equal to 2. Now, is there any multiply divide stuff? Nope. So what's the last thing you do? Power stuff. So we put it to the what? To the 4th. X equals 2 to the 4th, which is 16. All right. Moving on. This one. It's got a bunch of steps. This one's even got parentheses. Are they the last thing you do? No, they're close, though. All right, so first step, you do add, subtract stuff. Remember, this is the opposite of please excuse my dear Aunt Sally. You do add, subtract stuff first. So, adding 7. And I know this is such a pain to rewrite. Here's how I would do it. I just scribble this out and put 27 here. I know, but it's saving me having to write a lot, so it's probably okay. All right, and then I'm going to next, wait a minute. Didn't you say, Mr. Server, that you had to do all your add and subtract stuff first? And now you're going to tell me to do a power? This stuff has to be broken out of jail so that we can then go in and do the parenthesis last. Why would we go do the parenthesis last? Because it's normally first. See what I mean? Okay, so the exponent has to happen now because we're going in reverse order. There was no multiply divide to do. So then the next thing to do is the exponent. And the last thing we will do is the parenthesis stuff. Okay? All right, so next part is put it to a power of, and you need a 2 over 3 to the 2 over 3. You got trained in this. By now, you should be good at it. So random person. 27 to the 2/3. Row 2. Person 5. 2 almost in the back. Yes, you. Yep. 27 to the 2/3 is 3, and then you square it, makes 9. Good. So this is 9, and this is really messy. So I'm going to rewrite it. 3x minus 3. Now I'm doing the parenthesis part last. Does that make sense? Yeah, because we're doing things in opposite order. So, all right, now I'm going to add 3 to both sides. 3x equals 12. Divide both sides by 3x equals 4. Yay, it worked. Okay, try this one without any help from me. And let's see if you can get it. Try the one on the right-hand side. Completely on your own. I'm going to pause for a second while you try that. All right, so here we go. Your first step should have been to add 5 to both sides. And then you get 2x minus 4 to the 1/2 is equal to 7. And then I'm going to have to get this exponent fixed, so I'm going to square both sides. 2x minus 4 is equal to 49. Are you back with us now? Please be back with us now. All right, good. Now I'm going to add 4 to both sides. 2x is equal to 53. X equals 53. I feel like I'm doing something wrong here, but did you get 53 halves? All right, good. Cool. All right. So now we get that had a lot of steps, but it didn't really have any like super twists in it. Get ready to get twisty. This one's going to have a twist in it. And I bet, even with the warning, I bet only 5 people will catch it. Try it. I'm going to pause for a second. Let me try that. All right. By now, you've already added 8 to both sides. You know there's a twist coming. Could that possibly be part of the twist? No, it's not. X to the 2/3 is equal to 9. And then they put it to the power of, and I hope you put it to the power of 3/2, because that's not, there's nothing wrong with that. And then you go, okay, I can do this. Square root of 9 is 3, and 3 to the 3rd is 27. What is this twist he's talking about? Does anybody think they've got what the twist must be? What do you think? What do you think? You think it's plus and minus, and you're right. Okay, now, why would it be positive and negative, that number? Well, let me just show you that it would work. If I put 27 in, we know that works. We already checked it. Okay, it's 27. You take the 3rd root, which is 3, and then you square it. You see how squaring a negative would still have worked? See what I mean? Okay, so anyway, so that's 3, and then squared is 9, and 9 minus 8 is 1. How are you supposed to know that that was going to happen? Do you have to just like put plus and minus on everything? No. Here's how you can know it should have happened. You took the square root on both sides. Do you remember taking square roots on both sides in the past? Let's say we had this problem. Do you remember taking a square root on both sides and you get the absolute value of n? You remember that? We're taking square roots again. We're just doing it with fractions, so it doesn't feel like you're taking a square root, but you are. And when you take the square root of a variable, if you weren't in here first semester, you may not understand this, but you have to start rolling with it. When you take the square root of a variable, you get the absolute value. I proved it last semester by making kids graph this. And when you graph that, the answer is not x. The answer is the absolute value of x. If you graph that, it looks like that. You know that's the absolute value graph. And so then, if the answer is the absolute value of x, you should know that when you square root a variable, you get the absolute value of it. All right, so back to when you have a problem, here's the key line. Listen to this closely. When you have a problem and you have to take any even root, as in a fraction that has a 2 or a 4 or a 6 on the bottom, then you have to get this plus and minus thing in here. I know it's really easy to forget, and it will separate off some A's from B's. Some kids won't catch this on the test, and they'll get the B instead of the A. When do you have to do this? When this bottom part of the fraction, which is the root part, is even, you're taking a square root. Why don't we care if it's odd? Because you can have cube roots of negative numbers. That's a legal thing. You just get -2. That's not a problem. You don't need the absolute value for that kind. But it's when you're taking a square root, you can't do that. That's illegal. It's imaginary. That's why there's the difference between the squared and the 3rd. So if it's even on the bottom, I wish I had a snappy saying for this, kind of like if the glove doesn't fit, you must acquit. It was a famous saying from the O.J. Simpson trial. I need a saying like that for if it's even on the bottom, then you got to remember plus and minus. But it doesn't, like, you know, it doesn't have a snappy ring to it. But all right. So final answer for this puppy said, be careful not to lose a solution. If you just said 27, you'd be wrong. It's the absolute value of x is 27. So that means x will be 27 and x will be -27. And yes, it's okay with me if you have the absolute value in there. The next line can say x equals plus n minus 27. But you got to show me that you know there's an absolute value there. If you just skip that part and write plus minus, I reserve the right to take off partial credit. You got to say absolute values. Yes? Watch what we do to solve it. Did I just put this to an even root? Yes, and therefore there should be 2 answers to it, right? Okay, so let's do it quick. What's the square root of 4? 2 cubed is What's 2 cubed? 8. So you're saying 8, and you're saying negative 8 should also work, right? Because this is one of those same kind of problems. Don't be just, don't be down on yourself. You're acting like you're wrong or something. You're actually right. So I'm just asking you to prove it. If this works, why does this also work? Because you can do the cube root of 8, or negative 8. You can do that. It's a thing. It's negative 2. And then you can square it, and you'll get 4. So yeah, you're right. Both the one on the left and the one on the right both had that same issue. Because in solving it, we did a square root. An even root will cause this problem. That is the twisty part. That's the part that will separate the A's from the B's in this next test. They say in my advanced teaching classes, they say that's one of the best things you can do for kids is tell them where the common mistakes are. If you know that people often do this part wrong, you kind of pay more attention to that part. So it's okay to tell you the common screw-ups. All right, so let's get to one more kind. That doesn't look at all like one of those fraction things you were just doing. So let's make it into one. X plus 2 to the power of what fraction? I'm just rewriting the problem right now. I would rather have a fraction there. Is it 2/3 or 3/2? 2/3. Good. Now I can fix it. Put it to the power of, kids always say multiply it by, no. Put it to the power of 3/2. Is this one of those kind? Yes, it's got a root that's even on the bottom. So this is the absolute value of x plus 2. And then square root of 4 is 2, 2 to the third, 8. And then I bet you can solve it from there. X plus 2 is 8, and x plus 2 is negative 8. If you don't know how to do absolute values, you haven't mastered the top 20 yet. Then from there, we just subtract 2. We get 2 completely different answers. All right. Why did the absolute value happen? Because that right there. Even root. If you do an even root to both sides. All right, now your homework. Find your homework. It looks like this. I'll tell you which ones you can skip. Your homework says fractional exponents and solving for x homework. I want you to skip. I guess I don't mind if you don't skip, but I'm going to allow you to skip the following questions. You ready? 2 and 7. 4 and 9. You'll have to ask somebody nearby if you're not there yet. 13, 14, and let me look. I think it's 13, 14, 15 go together in a little block. Nope, just 13, 14. My bad. Problems 13 and 14 may be skipped. And also the last 2 questions. These 2 and the last 2 on the worksheet can also be skipped. All right. Now let's also zoom in on this problem. Do you remember me saying it's a trap? Do you remember the whole extraneous thing? Things that seem like they should work but don't are called extraneous. And there's going to be an answer for this. In fact, there's going to be 2. If you do it right, you'll get 2 answers. One of them won't work. Sometimes no answer works. When you have square roots on both sides, what do you think happens a lot when you stick your answer back in and you check to see if it works? You stick it back in, and why wouldn't it work? Because it comes out with a square root of negative. Do you get if I came out with an answer of like x was -1? As soon as you stick it in here, you're going to end up with -7 minus 20, which is -27. So you get the square root of -27 isn't even possible. So let's say that this side simplifies down to the square root of -27. And this side does too. And that's what will happen. Except it's not -27. It'll be something like that. And you're like, well, so it worked. No, these are both imaginary things. That can't really exist in the real world. So that means it didn't work. If you come out with a square root of a negative, that means your answer is extraneous. So watch out for that on that kind of question. The safest thing to tell you would be to check every single answer on every single problem. But I'm doing a little bit of like pre-screening to watch out. Which one do I have to watch out for? Did you know they do that at the airport? They have somebody watching the people in line. And sometimes they pull you out randomly. There are ones that are totally random. And there's other people they pull out of the line who they've been watching, like, keep my eye on that one. And you know why? If you're acting all fidgety in line, like you're really nervous about going through the, like, security thing, a lot of times it's because you're hiding something. Now, it could just be because you're nervous, because, like you're nervous that they're going to bust you for something even though you didn't do anything wrong. They try to separate those two, but if somebody's acting cool, but it's kind of fidgety, like they look a little nervous, they're trying to act cool, but they're trying to, like, you can tell they're hiding being nervous. Maybe they're smuggling something in their luggage. Maybe they're a bad guy that needs to be searched. So they spend extra attention. So there's somebody who is paid to watch people in line. And some of the experts at this, it's amazing what percentage of people they can pick out by looking at them. They look at them in line and go, that's a bad guy. I know it is. And then they go search him further and they find out, holy crap, he is a bad guy. He's on the no-fly list, or he's, hiding something, or he's got bombs in his shoes, or whatever. They can tell by looking at your mannerisms. One other thing they're looking for, by the way, is people that look like they feel a little sick. Why would they be looking especially close at people who look like they feel a little sick? Yes? That's true, but it's really hard to tell if somebody's actually sick. You know what they actually do with them? They x-ray them because they have swallowed something that they're trying to smuggle through security, and it makes them feel a little sick. And so anyway, so all I'm trying to say is we as math people also kind of keep an eye on problems, and we know to watch out for those kinds. If you got square roots on both sides, a lot of times you're going to have a problem with that one. You're going to get an answer and it's not going to work. Yes? Yeah, you can square both sides. Yeah, and it makes it really simple. And does squaring both sides need absolute values? No. So it actually seems really simple. And then you get through and you get an answer, and then a lot of times it doesn't work. So just watch out. This is us doing a little pre-screening to make sure that we don't have a mistake answer. All right. So that's all I got for you for today.